inverse t, just be careful with the inverse t when you put this in. The table 5 does a one-tailed versus two-tailed. If you use the inverse t, you have to split the two-tailed in half. If you use the table, you do not. The table always gives you the positive value. So if it's on the left-hand side of the 0, you make it a negative. If it's on the right-hand side of the 0, you make it a positive. The calculator gives you a negative. So, and the same thing applies. So I don't care which one you use. I find the table to be easier. You don't even have to think about it. One-tailed, two-tailed, and there you are. And what we're going to do is label this shaded region, reject H0, and fail to reject H0. We're going to label them that way. So that when we do this, we should be able to see where they fall. Everybody good with these cutoff points? Anybody can't find these cutoff points? I'm going to come down to 8. Good so far? Okay. Just to refresh your memories from the weekend, the two-tailed, if you're going to do inverse t on your calculator, and I fixed my calculator, so it now has what you have. Yes, but I couldn't. Oh no. No. It must not hold it, because every time I change it, it doesn't hold it there. Okay, so inverse t, you're going to say 0.05 divided by 2, and then degrees of freedom. And then that should give you, the last one you don't have to close. So remember, this gives you the -1 because you're looking at the area to the left. It gives you the negative. You have to then make the one to the right positive. Inverse t works the same as the inverse z, where you divide it in half. There's no 1 minus on this. Level of confidence, we want 1 minus, but not this. Because you only want that little tiny area to the left or to the right. We're good with this? You're going to label reject H0 and fail to reject H0. Okay, this guy, it just went through seeing what your decision would be. This is a decision that you make. You make this decision based on where your t test statistic. This is your critical value. I usually write it TC, cutoff critical value. This is your test statistic. That's the difference. This one you test, T equals. This one you find in your table or in your inverse T. That's the cutoff. Anything here in the shaded will say reject H0. Anything here will say fail to reject H0. So we look for where your points are located. Anything in the positive, fail to reject. T0, fail to reject H0. Negative 1.08, see where it's falling? Negative 1.08, it's still falling in the fail to reject H0. And this guy falls slightly to the left of your critical values. That was the reject H0 one. Good? Everybody has this. Good. So the second one, same thing. You're two-tailed. This is the reject H0. This is the fail to reject H0. Okay? Positive 1.705, that's in your fail to reject H0. Make sure you use H0. Negative 1.755, that's to the left of that. That's in your reject H0. Negative 1.585, that's in your fail to reject H0. And then the last one falls slightly to the right of the other critical value cutoff. Reject H0. We're all doing pretty good here. Okay, now this S, remember, you can't find your p-val off that table because your p-val doesn't work like table 5. Table 5 gives you your z-scores and gives you the area under your curve. Your t-curves are a family of curves. their area is always equal to 1 under the curve, but their curves keep changing. So we don't have a way to find the exact area. Your calculator can find your p-val. On your z-test, and there's a t-test right underneath it. Your t-test can find your area just like your z-test found your p-val. So this we're going to label rejection region. We're going to come here, take your 0.05, divide it by 2, or use your two-tail test. Take it off your two tails, positive and negative. Label your chart. Write your claim, your HA, pull out your sample information. You're going to get your standard deviation from your sample this time. This is the time we use T when we don't know your population standard deviation. It gives us a little bit more leeway in here. So we use your test statistic, which should say T. This is your test statistic, and we find your T-score to be 1.508. It falls in your failed to reject H0. Your claim was HO. Follow your chart. And we failed to reject it. That means we have to go along with it. We say there is not enough evidence at the level of significance of 0.05 to reject the claim that the mean price of a 3-year-old sports utility is $20,000. Okay? Everybody's good with this? Awfully quiet.
Oh,
You go from talking to very quiet.
With the
Now I would like you to talk to me, not before.
with the chart, are you the exact way to shape? Are you gonna know that?
Well, right now you're sketching. That tail, really in reality is this big.
Yeah.
Because it's figured out like a plus or minus 2. It's at plus or minus 2, that's unusual. So there's only plus or minus 2 is like 95%. Each one has like 2% in there, those tails. But if we wrote them this small, you really wouldn't be able to see where your data is. So you make them a little bit larger.
That's where you use the 0.05 and inverse norm.
And not inverse norm. And you can look up table 5, which is better because it has a two-tail. Excuse me. It has a two-tail versus a one-tail on table 5. If you want to look it up in your calculator, you have to use inverse T. And you have to, your calculators will say area, divide by 2, you just divide it by 2, and your degrees of freedom. Okay, next one, I wrote all Z's on these, not T's. Okay, your IRS claims that the mean wait time for callers is at most, that's less than or equal to. The equal to sign is an HO. The complement of that is greater than. So you follow the greater than sign and you've got a right tail test. This is from your sample. This is what you're going to test with. And you're going to see how extreme this is. This is way more extreme than your 2.426. So it's falling in your reject HO area. Because it's a T-score. We use this when we don't know our population standard deviation. You have to find it from your sample. So when we use a sample standard deviation, we have to use this.
And
We don't have a population standard deviation.
And where is it in the paragraph is?
Because it's in this whole unit.
Oh.
And where does it say that? A random sample of 40 callers has a mean wait time and a standard deviation. So the mean, this is the X bar, this is the X. So as soon as we don't know our population standard deviation, we have to use a T. And they have to tell us if our N, the same thing as before, if N is greater than or equal to 30, we're good. If it's less than 30, they have to say, assume that it's normally distributed. That part stays the same. When we find our decision, we go back to our table. Your claim is an HO. You're rejecting it, so you don't like it. You like this one instead, but you have to say there's enough evidence to reject the claim that the mean wait time is at most 15 minutes. Okay? Question?
That's not something new.
Well, we're going to do the same thing, but we do proportions now. Next. All right? An environmentalist estimates that the mean waste time, blah, 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 is more than 1 pound. This time our claim is our HA. Your HO is the complement, less than or equal to. Your tail is a right tail test. Find your T, and that's way, way, way extreme. That's way in the reject H0. And because we're rejecting the H0, we're liking the claim. So notice your table uses the word support when your claim is HA. So there's enough evidence at that level of significance to support the claim that the mean waste recycled is greater than 1 pound per day per person. It's a lot of waste. Right? These are all true. If they have the little statement underneath it, they're all come from something. Okay? Last of the reject regions, this is the is. You had to put this in your L1. You had to do a one bear stat. We didn't have this?
I said no, this one was, it gives you the mean information.
Gives you get the mean and you get your standard deviation. Now, if you use your t-test as well as your z-test and you use an L1, go to your data. It works the same way. So if you're in t-test, go to data after you put your L1 in. All they need you to do is put in this one because they don't know what your population one was. They know what your sample mean is. They know what your sample standard deviation is. Fill it in and you can go from there. And your tail, if they don't know what your tail is. So label it and you're in the fail to reject H0. There's not enough evidence at the level of significance of 0.05 to reject the claim that the mean salary is $26,000. Anybody have a question? Question?
We can just do the N equals the DF calculator, right?
There's no, well, if you enter your information.
Yeah. You can just do it in calculator, like right there.
Where in the calculator are you going to inverse T?
Yeah.
Is that what you mean? Mm-hmm. DF.
Right.
Mm-hmm.
This one is back.
Yes.
Take two.
Okay, this one I asked you to do by p-val. This one you need your calculator for. So everybody had to use the p-test in this. The only way to get your p-val for T is through your calculator, through a t-test. So you're going to pull this up. You're going to go to your t-test. It's right under your Z. And you're going to put all your information in. Put your mean. That's part of your claim. The population, this is in your claim. The X bar, pull out your sample information, your sample standard deviation, your N, and your tail test. You have a right tail test. It doesn't care about your level of significance because that's what you're going to test your p-value to. You're going to go to calculate and you're going to pull out your p-val. And it's very small. There's your z-score, your t-score. We just wanted your p-val right now and test against your p-val. Here's your p-val test. So since it's so small, it's more extreme than your 10%, you're going to reject H0. You still need a sketch. You don't need to go through the reject HO, the fail to reject, because you're not using that to reject it. You're using a p-val.
Wait, if you give us the p-val on a test, do we stop the sketches?
Well, you just have to give me what tail you are, but that's all you need to do for that because you don't really need the rest of it. You just need to tell me what tail you are.